Hi everybody, this is Mr. Folly, and welcome to, I'm not drawing. Welcome to me doing the homework with you. Woo! Okay, so you got a bunch of these things, and I know there's some pictures with the shapes on there already, but I want to go over how to draw the shapes for you and preview a bit of the other stuff that goes with it. So I've got PO4, -3, and I'm going to start with P in the middle because it's the least frequently occurring, and I'm going to look at, I want to remind you how to get the number of electrons. Okay, so here's a periodic table. Get my draw going on here. This has 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, really, all we're going to worry about are these guys over here. Okay. Because those are, remember, this is for covalent compounds only. Okay. This is my periodic table of electronegativity, so I hope you guys are looking at that too. So I hope that works. All right. So P has 5. Oops. Lost my draw. 1, 1, 2, 3, 4, 5. I'm going to add 4 oxygens at it. 1, 2, 3, 4. Okay. Each oxygen has 6 valence electrons, as we saw before. 1, 2, 3, 4, 5, 6. Notice how I'm aiming my single electrons at phosphorus. And this guy actually has a handful of different ways to draw it. And then I'm going to sing Connect the Dots. Connect the dots, la la la. Connect the dots, la la. Remember, we're not allowed to have single electrons. So what I'm going to do first is I'm going to get rid of this guy, put him over here, and make a double bond. Okay? I'm going to erase that guy I got rid of. Okay? Now, this is a bit new for us. Okay? So we've got something with a charge of -3. If you're -3, that means you're going to add 3 negative electrons. And I can put them anywhere I want. Remember how we're the master of the electron? So I'm going to change my color of this. Not that it really matters that much. These aren't any different than any other ones. But I'm going to add 3 electrons. 1, 2, 3. And to indicate that this has a charge, I'm going to put a -3 on the outside there. Okay? Now, remember, if we're a little leery about this, we can count to make sure we've got 8. 2, 4, 6, 8. Oxygen's happy. 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 Then I've got phosphorus. 2, 4, 6, 8, 10. Uh-oh. 10 is not 8. So that means I'm going to double check to make sure that phosphorus actually is allowed to break the octet rule. Remember, this is period 1, period 2, period 3. Phosphorus is on the 3rd period, so it's allowed to. So that's okay. Okay. I'm going to name this shape. This shape has 4 regions. Oops. This shape has 4 regions. When I look at my shady shape sheet, if I have 4 regions and no lone pairs, the name of the shape is tetrahedral. Okay. And now I've got to give the bond polarity of each one. So that means I got to look at phosphorus's electronegativity and oxygen's electronegativity. So phosphorus's electronegativity is 2.1, oxygen is 3.5. 2.1, sorry, 2.1 and 3.5. If I subtract those, equals 1.4. I don't know why I did that. 1.4, which is polar. And then I'm going to draw the arrows. Remember, oxygen is more electronegative, so I'm going to draw the arrows at it. I'm going to change my color so it looks more pointing at the more electronegative oxygen. And I draw all 4 of them. Okay. Now, what I didn't do was draw the shape. I drew the Lewis dot structure. I'm going to draw the shape. So P, oops, O, 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 O. And that should look tetrahedral. Okay, let's go to the next one. CH4, draw the shape. Carbon goes in the middle. 1, 2, 3, 4. 4 for the valence. Throw my H's around it. Each H gets 1. Again, looking at those valence electrons we talked about before. La, 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 connecting the dots. Again, name the shape. It's got 4 regions again, right? No lone pairs on carbon. So I'm going to draw it now. H, 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 H. 4 regions, again, is tetrahedral. Give the bond polarity. Carbon is 2.5. Hydrogen is 2.1. If I subtract that, I get 0.4, which is nonpolar, which means no arrows. SF4, draw the shape. This one's tougher. S, 1, 2, 3, 4, 5, 6. F, F. Hi, Penny. F, that's my dog, sorry. F has 7 valence electrons. The periodic table tells me that. Connect the dots, la, la, la. Connect the dots, la, la. Okay, so now, notice I don't have any charges, so I can't add any electrons or take any away. I have single electrons, which are evil, right? So I can't have single electrons, but if I have 2 single electrons, what I can do is I can pick those single electrons up, or I can try to, but it won't let me. I can pick those single electrons up. Boy, it won't let me. I can pick those 2 up, and I can make them a pair, right? So if I pick those 2 up and make it a pair, I can then work with that, okay? So now notice every fluorine has 2. Man, what am I putting my hand on that's moving this so much? So every fluorine has 8, 2, 4, 6, 8. Sulfur has 10, right? Pair, and then 4 bonds. So let's look and see if sulfur can have 10. Every time we break the octet rule, we got to check it. Here's sulfur. It's on the 3rd row or below, so it's a winner. So go back to it. So now I've got to name the shape. And the shape that I'm going to name it is, it's got 5 regions this time. So 5 regions is based on trigonal bipyramidal. But it has 1 pair. So if I have 4 bonds and 1 pair, I'm going to look like this. And this is the shape. This is my drawn shape. And the name of that shape is seesaw. Okay. Now I've got to give bond polarity. Okay. So F I know is 4.0, but I forgot what sulfur is. So I need to go back to my periodic table. Sulfur is 2.5. Fluorine is 4.0. So F, oops, I'll go over here. F is 4.0. S is 2.5. When I subtract that, I get 1.5, which is polar. That means I do need to draw arrows. I'm going to point my arrows at the more electronegative one, bigger number right here, which is fluorine. All done. CSE2. Uh-oh. I don't know this one very well. Carbon has 4 valence electrons. Se, I'm not sure of, to be honest with you. Got to find me some selenium. Se, 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 Se is right here, okay? So Se has 6 valence electrons. I'm going to erase that to make sure that's Se. It is. So I got 6 valence electrons for Se. So SE 1, 2, 3, 4. Notice I'm pointing my single electrons where I know they're going to bond. Connect the dots. La, la, la. Okay, got singles here. So I'm going to do that. I've got singles here. And do that. Okay, I'm going to erase the ones that I X'd out. Why we do these in pencil. Okay, so there's that one. This one actually is the shape. So notice it has 2 regions. So it's going to be linear. And then I've got to give the bond polarity. So carbon, I know, is 2.5. Selenium, I forgot. I should have looked when I was looking before. Selenium is 2.4. I almost remember to touch my pen first. 2.4. 2.5 minus 2.4 is 0.1, which is nonpolar. And nonpolar is no arrows. That's it. Water, my favorite. Oxygen has 6 valence electrons. Hydrogen has 1 valence electron. Water is one of the trickier ones there is. Okay? First I get to sing, connect the dots, la, la, la. Doesn't that look linear? So remember when it says name the shape, I always write down how many regions. 4 regions. Region 1, region 2, whoops. Region 1, region 2, region 3, region 4, right? So if it has 4 regions, it's based on tetrahedral. And if you look at tetrahedral, it doesn't have anything linear in it, right? So tetrahedral looks like this. Okay? Pyramid with a flag on top. So what I get here actually is H, bent. So name the shape, it is bent. Okay? Bond polarity, it's kind of sad, but I know oxygen is 3.5. Hydrogen is 2.1. That's 1.4. So that's polar. I'm going to draw my arrows from positive hydrogen. This is the low one, positive, to my high electronegativity oxygen. H2CO. Again, carbon always goes in the middle. 1, 2, 3, 4. Oxygen O, aiming my single electrons at carbon and aiming my hydrogens out there. Connect the dots. La, la, la. Oh, see these? I can make a double bond. I'm going to erase those 2. There you go. We got it. Okay. Now I've got to name the shape. This one has 1, 2, 3 regions, no lone pairs. So it's going to be trigonal planar. Give the bond polarity. So I've got some different bonds here. I've got C, which is 2.5, to H, which is 2.1, which is 0.4, which is nonpolar. Okay. And then I have C, which is 2.5, and O, which is 3.5, which is 1.0, which is polar. So I don't do any arrows for this one, but I do need an arrow for this one. Drop it in there. Oh, I didn't draw the shape though. Remember, if it's trigonal planar, I've got to make it look with a 120-degree bond angle. Okay. Cruising right along. GeF2. Uh-oh. I don't know what germanium looks like. So let's find germanium on our periodic table. Here it is. Germanium is like carbon. It's got 4 valence electrons. So, oops. Guess it's going to do that every time. GE, it's going to have 4. 1, 2, 3, 4. I've got F2. Uh-oh. F and F. Each F has 7. Connect the dots. La, la, la. Now, for a second, I might think, oh, man, I could probably double bond this, but I can't because I don't have single electrons for F. So what I'm going to do is I'm going to take this single, right? I've got 2 singles right now, and change 2 singles into a pair. Okay, so I picked that one up and made it a pair, and I'm all set with that now. Okay, so now I have 3 regions. See, I have 3 regions with 1 pair, it's 2, then 3. Remember, we're only counting the regions on the central atom, only on the central atom. So then, if I have 3 regions, but I have 1 pair, so 2 bonds, 1 pair, that's going to be bent. And that name is bent. Okay, so now I have to get the bond polarity. So F is 4.0, GE is, I forgot. I didn't look, to be honest with you. GE is 1.8. 1.8. 1.8. And that difference is going to be 2.2. Right? So that's going to be ionic. Now remember, ionic is superpolar. Right? So I'm still going to draw the arrows, pointing at the more electronegative ones. Right? If I did it on this shape, it'd be like that. BCl3. Boron. If you remember, boron and aluminum are special cats. They only need 6 electrons to be full. Connect the dots. Oops. La, la, la. So boron only needs 3 to be full. So 3 bonds for happiness. Okay? And remember, boron and aluminum are the only ones that are like that. Okay? So I drew it. Now, if I have 3 regions, again, the name of it's going to be Trigonal Planar. I don't have any bonds. Okay? Now you do bond polarity. Okay, so let's take a look at chlorine and boron. Chlorine 3.0, boron 2.0. So chlorine is 3.0, boron is 2.0. The difference is 1.0. So that's polar, so I need to draw arrows. Well, first I need to draw this shape correctly. Somebody bumped me.
Sorry.
Okay, so this is the shape. Now I'm going to draw it at the more, point the arrow at the more electronegative one. I'm going to put my dots in here now. And remember, boron only needs 3 bonds, which is a weird ducky, but that's what it is. CH2F2. Ooh, tricky, tricky, tricky. Remember, carbon's going to go in the middle whenever it can. 1, 2, 3, 4. Adding an H. Adding an H. Bond, bond. Adding an F. Adding an F. Connect the dots. La, la, la. Now, for to name this shape, this has 4 regions. Notice that one of the most popular ones. Naming that shape is tetrahedral. But I have to try and draw it. Carbon, hydrogen up, fading back, and I'm just cheating off of my shady shape sheet, which you should have printed. Okay. Oops, I wrote it wrong. Dun, dun, dun. It's not CH4. It's CH2F2. It doesn't matter really where you put the F's, as long as it's not in chemistry. Okay. So CH2F2, and then give the bond polarity. Okay. So I hope you remember C to H is always nonpolar. Okay. And then F was 4.0, And carbon was 2.5. So that bond polarity is 1.5. So I have to draw it for that one. I'm going to change my color. And remember, I go from my positive one to my negative one. From my positive one to my negative one. And there you have it. Man, he's going forever. Draw the shape. P, H3, H, H, H. Every hydrogen has one. So again, I get the dots from the number of valence electrons, which comes from the periodic table. Okay. I've drawn my dots around all of them, and I connect the dots. La, la, la. Connect the dots. La, la. Man, this one's being mean to me.
There's so many of them.
Okay. Name the shape. That shape, from looking at my shady shape sheet, is Trigonal Pyramidal. 3 bonds. 1 pair. 1 pair. 4 regions. So I'm going to draw this now the way I should have drawn it before. H, H, H. And give the bond polarity. P is 2.1, H is 2.1, so it's 0, so it's non-polar. All right. How many more do I have? 1, 2, 3. No, stop. 4, 5. Ah. Okay. So I'm going to stop the description through all these and just draw them. Same process, just giving you guys the answers now. Oops, I connected the dot in my eye. That's no fun. Connect the dots. La, la, la. 4 regions. So it's going to be tetrahedral. Okay, that's what the shape looks like. The name of the shape is tetrahedral. And the bond polarity is going to be polar because the change, delta means change, and electronegativity is greater than 0.4. AsCl3. As, I'm sorry to say, I don't know how many valence electrons As has off the top of my head. So I'm going to look just like you do. As is right here, so it has 5 valence electrons. Oops, I hit the same one again. As has 5. 1, 2, 3, 4, 5. Cl3. Cl has 7. Cl has 7. Connect the dots. La, la, la. And the name of the shape is going to be Trigonal Pyramid again, because I have 4 regions, 3 bonds, 1 pair. I'm going to draw it so you can see it. Cl, wedge Cl, line Cl. Bond polarity is polar, I'm pretty sure. As is 2, Cl is 3, yep. So it's going to be polar. It's polar because 1.0 is the difference in electronegativity. So I'm going to draw an arrow pointing at the more electronegative guy. There you have it. Cl2O, draw the shape. O is going to go in the middle. There you go. Draw the shape. Oh, that's the structure. Draw the shape. Notice it's got 4 regions, but it's got 2 pairs, so it's going to be bent. So I'll draw it bent. Here's O. This is a tricky one because when you look at it, doesn't it look like it would be linear? But it's not, because remember, it's based on 4 regions. It's based on tetrahedral. O to Cl. Actually, no, that is the difference in electronegativity. Difference in electronegativity is, where are we? Delta En is 0.5. So I got to draw oxygen's more electronegative. There you go. AsH3. As has 5. It's a pair. H, H, H. Connect the dots. La, la, la. The real shape will be based on tetrahedral again. See how popular that tetrahedral is? And that's going to be trigonal pyramid, for the name of that shape. If you make it a noun, it's trigonal pyramid. If you make it an adjective, the shape, it's a trigonal pyramidal shape. The bond polarity, I don't know. So As is 2, hydrogen is 2.1. So 2.1 minus 2 is nonpolar. Nonpolar, which means no arrows. SO3. S goes in the middle, least frequently occurring. O, O, O. Each one has 6. Connecting the dots. La, la, la. Connecting the dots. Okay, so I connected the dots. I'm going to make a double bond with this one on the bottom here. So I'm going to move this guy here and do that. And erase that. Now I've got single electrons left, and that's bad. We know that, right? So if single electrons are bad, remember we are the master of the electron. So we are going to take these 2 electrons. We're going to erase them. We're going to put one right here. And we're going to put the other one, whoops, the first one didn't show up. One right here and the other one right here. And this is great because I would still have 1, 2. Oh, why does it do that? I still have 1, 2, 3, 4 bonds, which is 8 electrons, which keeps it stable. Okay. So on this one, I have 3 regions. So 3 regions means it's going to look like this, which is going to be trigonal, not pyramid this time, trigonal planar. Again, that shady shape sheet tells all. The bond polarity is S and O. I know it's polar, but I remember 2.5 and 3.5. So 2.5 and 3.5, the difference is 1. So if the difference is 1 for the electronegativity difference, I'm going to draw my arrows at the more negative one. There you have it. BBR3. All right. So boron's going to go in the middle. And remember, boron only needs 6 electrons or 3 bonds. Bromine has 7. And I connect them. Connect the dots. La, la, la. The shape is going to be trigonal planar again because it has 3 regions. The bond polarity, boron to bromine, boron to bromine, boron is 2, bromine is 2.8, that's polar, because when I subtract it, so whoops. So 0.8 is polar, so I'm going to draw this as trigonal planar, and I'm going to draw my arrows at it. Bromine was more electronegative. And was bromine more electronegative? I don't remember. Bromine was 2.8. Boron was 2.0. It was. Sorry, short-term memory. HCN is the last one. Yay! Remember, carbon goes in the middle every chance it gets. Nitrogen has 5. Hydrogen has 1. Connect the dots. Oh, look. Triple bond. La, la, la. Connect the dots. La, la. There you go. This dude is going to be linear because it only has 2 regions. 1 region, 2 region. It spreads out as far as it can. Bond polarity, C to N is polar. C to H is nonpolar. Remember I told you to memorize C to H is nonpolar? That's a wise thing, my friend. Very wise. I think that's it. Oh, no, I got one more. PF5. PF5, I'm going to draw this one. And put my dots around it. I did this right to the 3D shape because you don't want to watch this anymore. And I hope you're skipping around through this. So there's PF5, there's the shape. The bond polarity, I'll name the shape, is Trigonal Pyramidal. The bond polarity is polar because the difference is greater than 0.4. And draw the arrows. Let's do them in a different color. Fluorine's more electronegative, more electronegative, more electronegative, more electronegative, more electronegative. There you go. And, oh man, this one looks almost exactly the same. P, whoops. What? PF5BR? That's not right. I'm just going to say skip this bad boy. I'm so sorry. The reason why I say that is it's got to be a typo because what would go in the middle? Oh, no, it's not. What's going to go in the middle, I guess, is going to be bromine because the only one, I'll do this for fun. You can skip it, but I'm just going to have fun doing it. Bromine is the only one that can break the octet. Because how do you know that? Well, I've got phosphorus. Oh, I guess phosphorus could. I've got fluorine, but bromine's down here and it's got a lot of electrons to bond. So that's a tricky one, but we'll put P in the middle. P, oh my goodness. P right here, 1, 2, 3, 4, 5. This has 6 bonds, and this is where it gets kind of weird. Oh man, why'd you do that? So because I know it can't form 6 bonds with 5 electrons, I'm just going to go ahead and make the executive decision. We'll put bromine in the middle. So that's going to be 5 F's, 1, 2, 3, 4, 5, and then we get a P down here. All right, so we got a single electron for all the F's. Okay, so, man, I don't like this one already. Okay, so I'm gonna make a bond here. And then I guess I'm gonna double bond, and I'm stuck. Oh, I guess I'm gonna go back with my skip it. Oh, skip. I think I might have drawn it on the sheet that I gave you. But that's it. And the bond would be polar. The bond is polar. But this is a big skippy one. Tears. And that's it. That's the good news. So I'll end on that bad dude and say toodles.